Hey everyone, welcome to this App Inventor tutorial series. In tutorial 1, we have created an app that acquires real-time air quality information at your current location. Today, we'll be looking at how to obtain air quality information at any location on the map in Hong Kong. Again, we'll use Praise Hong Kong web service and its extension in our app to receive the air quality information. Praise Hong Kong is a web service for air quality information such as AQHI and the concentration of various air pollutants with high data density and high accuracy, and is able to provide 48-hour forecasted air quality information. To access Praise Hong Kong data, our team has developed an extension for users. All the details of the steps that I'm going to show you is in the tutorial guidebook available on our Praise Hong Kong website. Without further ado, let's dive into a tutorial. Let's go ahead to our MIT Inventor website and create a new project. Name it as Get Air Quality from Map. We're now in the Designer tab. To create a user interface, we'll do that here. First, we have to import the Praise Hong Kong web extension. Go to Extension and click Import Extension. Then, from the box popped up, click the URL button and then input the URL, which can be found in the guidebook on our website. If the import is successful, the extension section will turn into this. Now, drag this onto the phone, just like other components, and the extension is ready for use. Next, we're going to drag other non-visible components in the palette column onto the phone too. These non-visible components will be displayed under the phone once successfully imported. If everything's alright, it should look like this. We'll move on to the visible components. In the top area, we drag and drop various visual components onto screen 1 and set the user interface properties. To begin with, drag the horizontal arrangement into the screen and align it to the center. Next, we'll create a button to generate the results. Rename the button to Get. Then, we need a spinner for us to choose among various types of air pollutants, and input the air pollutants names. Lastly, the labels to show the pollutant values. In the middle area, we just need to drag and drop a map component onto screen 1 under the top area and set the center from string on the properties as suggested. In the bottom area, we're going to create a spinner. This is to set the number of hours to the future when predicting air pollution. In this area, we drag and drop the various visual components onto screen 1 to create a slider. This is to set the number of hours to the future when predicting air pollution. Lastly, the labels to show the hour value. The interface will look like this if everything's correct. The user interface is now complete. Next step will be the implementation of the behavior. We'll do that in the Block Editor tab. The global variables current lat and current long are used to store the current latitude and longitude chosen by the user, while the map marker is used to store the map's marker component. At the beginning, all are set to an empty string, meaning that nothing is stored in them. If the user taps any point on the map one tap at point event handler will be run, and passed in the latitude and the longitude value of that point. If currently there's no marker set, it will be created using the map1 create marker method and then assign it to the map marker. Otherwise, the marker will be relocated using the marker set location method, so that the marker will always appear at the point the user taps. Also, inside the handler, the current lat and current long are assigned the values of the latitude and the longitude. These two global values will be useful in the other parts of the app. Finally, we set the air quality value text back to nil, as any new tap on the map will invalidate that value. Remember we have a slider at the bottom area on the screen? We're going to create that as well. When the slider's thumb is dragged to a new position, the slider's position changed event handler will be called. It passes in a thumb position, telling where the position is. The rounded value of the thumb's position sets the hour value text property displayed on the user interface. The value is rounded to an integer because Praise Hong Kong service only forecasts the underground hour value. Then, we set air quality value text back to nil, as any new position on the slider will invalidate that value. After that, we set the spinner to choose the type of air quality information we want to view. Now, let's create the function of the Get Air Quality Value button. As the name implies, we want to get the air quality information after clicking it. In order to do this, we have to send a web request to the Praise Hong Kong web service. What we do here is that when Get Air Quality Value button is clicked, its click event handler will be called. Inside the handler, we have to first beware that the user may not yet pick a point on the map. The quickest way is to check either the current lat or the current long is filled with a non-empty value. Here we check the current lat. If it's indeed an empty value, we'll stop processing and show an alert using the notify1 show alert method, prompting the user to pick a point first. If it's a non-empty value, we'll continue the process. To send a web request, we first have to construct a URL. It's very much the same as trying to get a web page using a browser. We can use the Praise Hong Kong Web's extensions, Praise Hong Kong Web 1 generate URL to get a URL. The parameters it needs are the longitude, latitude, and the time instant. The longitude and latitude are provided by current long and current lat, while the instant is provided by using the clock component, and the hour value selected by the user. To handle the response from the web request, we use various event handlers. The first one is when there's no response. In case of no response, the Web1 timeout event handler will display a pop-up alert with a message, response timeout. If there is a response, we handle it using the following block structure. When there is a response, it will be handled by the Web1 GotText event handler. Inside it, we first need to test if the response is valid by calling Praise Hong Kong Web1 is response valid. Pass all the response data into it and let it decide whether the response is alright. If the response is alright, extract the value you need by calling the corresponding Praise Hong Kong Web1 method. Set the air quality value text property to display this value. And finally, completed by displaying a message done using notify1 show alert. If the response is not alright, display a data invalid alert using Notifier 1 show alert instead. After adding these final blocks, you can now test it using AI Companion or compiling it to an APK file. The app should look like this on your AI Companion screen if it's working. This is the end of this tutorial. Thanks for watching.